Picture this. You wake up tomorrow morning, check your phone, and see every satellite system worldwide has gone into critical alert mode. You step outside, and even though it's noon, the sky is ablaze with brilliant dancing lights, auroras, where they should never be. Then comes the announcement that changes everything. Earth's magnetic field has vanished. In that single moment, our blue planet becomes a naked battlefield, stripped of the invisible armor that's protected us for 4 billion years, now facing the full fury of solar radiation. This isn't science fiction. This is what the physics actually tells us would happen. Before we dive into this catastrophic scenario, drop a comment with your city and country so I can see where my viewers are watching from around the globe. And trust me, you'll want to stick around until the end, because what I'm about to reveal about Earth's fate without its magnetic shield will fundamentally change how you think about the ground beneath your feet. Let's begin with the science. For Earth to suddenly lose its magnetic field, we need an extreme event occurring nearly 3,000 kilometers below our feet. The outer core, a churning ocean of molten iron and nickel as hot as the surface of the sun, would have to stop moving. The geodynamo, that magnificent natural engine that's been generating our protective magnetic field through electrical currents in this liquid metal, would need to shut down in mere hours. Now, from a physics standpoint, this is extraordinarily unlikely. But in our hypothetical scenario, let's assume it happens. The magnetic field strength plummets from its normal 30 to 60 microteslas down to essentially zero. And here's what's critical to understand our magnetosphere, that enormous magnetic bubble extending tens of thousands of kilometers into space that's been deflecting charged particles from the sun. It collapses entirely. But here's something many people get wrong. The atmosphere doesn't vanish instantly. That's not how physics works. Instead, it becomes vulnerable to erosion over time, much like what happened to Mars when its magnetic field disappeared roughly 4 billion years ago. That planet's atmosphere was slowly stripped away, leaving it the frozen desert we see today. The moment the magnetic field disappears, the solar wind, a supersonic stream of charged particles racing away from the sun at 400 kilometers per second, no longer gets deflected around Earth. These high-energy protons and electrons, which normally spiral along magnetic field lines toward the poles, now slam directly into our atmosphere from every direction. Within the first few hours, ionizing radiation levels at high altitudes spike by 50 to 200 times normal levels. For anyone on an airplane, particularly on polar routes, this becomes immediately life-threatening. Pilots and passengers would receive radiation doses equivalent to dozens of chest X-rays every hour. Every aircraft in flight would need to land immediately, and all high-altitude aviation would cease. Astronauts aboard the International Space Station and other orbital facilities would face an even grimmer situation. Without Earth's magnetic protection, they'd be exposed to potentially lethal radiation doses within days. An emergency return to Earth would be their only option, assuming their spacecraft systems haven't already been damaged. But here's where it gets visually spectacular. Auroras would appear everywhere on Earth. These dancing lights, normally confined to regions near the magnetic poles, would now manifest at the equator in the tropics over every city on the planet. The sky would fill with crimson and violet curtains of light as solar particles excite oxygen atoms throughout the upper atmosphere. It would be beautiful, haunting, and absolutely terrifying, nature's warning that something has gone catastrophically wrong. Now, if you think the radiation is bad, consider what happens to our technology. Modern civilization runs on electronic satellites, GPS power grids, and global communications. Every single one of these systems depends on Earth's magnetic field for protection against solar storms. Without the magnetosphere, plasma waves and high-energy particles would induce massive electrical currents in power lines, transformers, and undersea cables. This is called geomagnetically induced current. And in our scenario, it would occur at levels hundreds of times stronger than the famous Carrington event of 1859, the most powerful solar storm in recorded history, which set telegraph systems on fire. Within hours, we'd see cascading power grid failures across entire continents. Transformers would overheat and explode. The electrical infrastructure that took over a century to build would be crippled in a single day. Satellites would fare even worse. Low Earth orbit satellites, which number in the thousands and provide everything from weather data to internet connectivity, would be bombarded by unfiltered solar radiation. Their electronics would degrade rapidly. Conservative estimates suggest 60 to 70% of these satellites would fail within the first week, becoming expensive, useless debris circling a dying world. GPS systems would fail. Navigation would revert to pre-digital methods. The Internet's backbone, which relies on precise timing from satellites, would fragment. Global communications would collapse into regional networks, then local ones, then nothing. Here's where the physics gets truly sobering. The solar wind doesn't just damage our technology, it physically strips away our atmosphere atom by atom. Right now, Earth loses about 3 kilograms of atmosphere to space every second. This sounds like a lot, but our atmosphere masses 5 quadrillion tons, so the loss is negligible. However, without magnetic protection, atmospheric loss could accelerate by 100 to 300 times. The upper atmosphere, particularly the ionosphere, would be hit first. This layer, which currently reflects radio waves and enables long-distance communication, would become so disrupted that shortwave radio, our backup communication system, would become nearly useless. Over months and years, lighter elements like hydrogen and helium would be preferentially stripped away. The atmosphere wouldn't disappear overnight. Earth's gravity is strong enough to hold most of it, but the composition would gradually shift. The protective ozone layer, already under stress, would thin dramatically as oxygen molecules are broken apart by unfiltered ultraviolet radiation. Now let's talk about what this means for life itself. Cosmic rays, those high-energy particles from distant supernovae and other violent cosmic events, are constantly bombarding our solar system. Earth's magnetic field normally deflects most of them. Without that protection, surface radiation levels would increase by 2 to 5 times, depending on latitude and altitude. For humans, this translates to a dramatic spike in cancer rates, particularly skin cancer and leukemia. But we're hardy. We can hide, build shelters, develop protective technologies. The real victims would be the foundation of Earth's food chain. Consider phytoplankton, those microscopic organisms drifting in the ocean that produce half of Earth's oxygen and form the base of marine food webs. They're extremely sensitive to ultraviolet B radiation. Studies show that even a 20 to 30% decline in phytoplankton populations could trigger a catastrophic collapse of ocean ecosystems. Fish populations would crash. Coral reefs, already stressed by warming oceans, would die en masse. Within a few years, we'd be looking at the 6th mass extinction event. But this one caused by physics, not an asteroid. Land ecosystems would fare somewhat better initially, but the increased mutation rates from cosmic ray exposure would accelerate evolutionary pressure beyond what most species could adapt to. Plants could develop protective pigments. Animals could become more nocturnal, but many wouldn't adapt fast enough. Fast forward 1,000 years, 10,000 years. What does Earth look like? The planet wouldn't have lost its atmosphere completely. Our gravity is significantly stronger than Mars, but the upper atmosphere would have thinned considerably. Oxygen and hydrogen, being lighter elements, would continue to escape into space. The greenhouse effect would weaken as atmospheric density decreased, leading to gradual cooling of several degrees globally. But here's the truly chilling part. The surface would become increasingly hostile to complex life. Persistent cosmic ray bombardment would cause genetic damage accumulating across generations. Cancer would become not just common, but nearly universal among long-lived organisms. Evolution would be driven by radiation resistance rather than traditional survival traits. Humanity would face a stark choice: adapt or retreat underground. We'd need to construct massive underground cities with artificial magnetic shielding, or develop technologies to create localized magnetic fields strong enough to deflect solar wind and cosmic rays. The cost would be astronomical, potentially 10 times global GDP annually, just to maintain basic protection. Surface dwellers would live under artificial magnetic domes or rely on personal radiation shielding. Agriculture would move entirely indoors or underground using artificial lighting. The surface of Earth would transform into a harsh radiation-scoured landscape where only extremophile organisms could survive. This is the future that awaits any planet that loses its magnetic protection, a slow, inexorable decline from vibrant world to barren desert. Now, before you start building your underground bunker, let's address the probability of this actually happening. Could Earth's magnetic field vanish suddenly within hours or days? The answer is almost certainly not. I'd give it a 0.1 out of 10. Probability essentially impossible. The outer core of Earth contains roughly 10 to the power of 21 kilograms of molten iron. The thermal and kinetic energy required to stop this fluid from moving would be equivalent to thousands of trillions of tons of TNT more energy than exists in Earth's entire crust. However, a gradual weakening over thousands of years, that's much more plausible. I'd rate it 6 out of 10. In fact, it's happening right now. Earth's magnetic field has been weakening by approximately 10% per century for the past 150 years. We're possibly in the early stages of a magnetic pole reversal, an event that has occurred hundreds of times in Earth's history. During these reversals, which typically take 1 to 10,000 years to complete, the magnetic field doesn't vanish. It becomes complex and multipolar before reorganizing. We'd see increased auroral activity at unusual latitudes, elevated radiation exposure, and some technological disruptions, but not the apocalyptic scenario I've described. The geological record shows that life has survived every magnetic reversal in the past 800 million years. So while concerning, it's not an extinction-level event by itself. So what's the final verdict? If Earth lost its magnetic field, we wouldn't face immediate annihilation. No dramatic explosion, no instant death. Instead, we'd experience what I call a slow apocalypse, a gradual, relentless degradation of conditions over decades, centuries, and millennia. The first days would bring technological chaos and radiation hazards. The first years would see ecosystem collapse and disease. The first centuries would witness atmospheric erosion and forced adaptation, and over thousands of years, Earth would slowly transform into a Mars-like world, still habitable, but only for those organisms capable of surviving in one of the harshest environments in the solar system. Humanity might survive through technological innovation, genetic engineering, or retreat into protected environments. But the Earth we know, with its blue skies, abundant life, and protective magnetic embrace, would be gone forever, replaced by a planet that exists in a state of perpetual siege from the very star that once nurtured its life. This is why that invisible magnetic field, something most people never think about, is quite literally the difference between a thriving world and a dying one. Every moment silently, and without fanfare, it's protecting everything we know and love from the hostile radiation environment of space. So the next time you use GPS, watch auroras, or simply walk outside under a clear sky, take a moment to appreciate the magnetic shield you can't see, but absolutely cannot live without. Because as our thought experiment has shown, without it, Earth's fate would be sealed not with a bang, but with a billions-year whimper, as our once blue planet slowly fades into the red desolation of a cosmic graveyard.